Our project is once again about intelligent internet traffic classification, in which we have used machine learning techniques to classify the data, and this is an unconventional technique. Since we know that the internet is exchanging billions of bytes a day, and the classification can help us in better managing the network and devising a network security scheme. Also, the classification can be challenging task because the network data is always random. This is one captured example packet using the Wireshark. It's containing different features such as IP address, port addresses, and etc. So I would like to call Qasim to explain this was part of my project.
Thank you, Salah. I will explain traffic classifications. Traffic classifications can be conventional based or intelligent based. Conventional based can be IP based or port based. Port based, for example, can be applied for web application or peer-to-peer applications. Web applications such as HTTP or TCP or FTP. So these are classifications for web applications, and the peer-to-peer applications can be, for example, like tolerant software. And also we have another type. This is the type that we choose to work on it, which intelligent machine learning classification. Intelligent machine learning classification can be supervised or unsupervised. Supervised needs training. Here the classifier needs training to do its job. But unsupervised, here the classifier now is very smart, very clever, because he just follow a specific algorithm or specific routine to do its mission. Actually, we applied unsupervised learning can be applied by a clustering method. Actually, we chose supervised learning to apply our project, and we applied that on by support vector machine, because we tried to do it with the naive Python, but our data it's randomly distributed. So we find that the support vector machine is the best method now to do it. Support vector machine can be binary class or multi-class. Binary class can be false or true or false, 0 or 1, A or B. So it's just two options. Multi-class can be more than 3 because actually internet traffic it has many options. So we choose to apply our work on multi-class classification. The methodology that we do, actually we start capturing the data from the internet on real time by using Wireshark software, and after that we claim our data by from the irrelevant information on the records from the records. Then we start preparing the data by labeling the data according to its type. Then after that we turn to make training for data. Actually in training stage we split our data into two portions. The first portion for training and the second portion for testing. Here for conventional we split it 70% for training, and for testing just 30%. And here the training was just done in one iteration. However, in training in cross-validate support vector machine, this is another approach for two training data that we applied also with the conventional SVM. Actually, the training and testing, it was in 10 false times. So the iteration for training, it was 10 times between training and testing. And I will we test unseen data, the data that in our record we tested to find the performance of our or to observe the performance of our classifier, and then we gather data and we analyze the data to find the results. And I will leave you with Salahuddin to explain the. Yes.
So this is how our data looked like before classification, and after applying the conventional classifier, we can see that the TCP packets are classified well, and there are some misclassifications for other type of packets, but our cross-validation classifier is performing better than our conventional classifier. And when it comes to the learning, it's always better to plot the confusion matrices, and they actually show you the relationship between the predicted class and the actual class. Another type of results are the efficiencies of the classifier. We can see that the misclassification loss are of two types: k-fold loss and the loss. So conventional loss is higher than the cross-validation loss, and its correction rate is also less than the cross-validation loss. And specificity and sensitivity, which are true positive rate and true negative rate, they are almost close to 99%. Or almost 100%. So we can say that our classifiers are having correction rate up to 95%. It means that this machine learning could be applied for the traffic classification purposes. And other conclusion could be that that our conventional classifier is having less computational complexity as compared to the cross-validated classifier. And for the future work, what we have suggested a system that a real-time system which can capture and classify and filter the traffic using our methodology. It needs to be implemented, and also we can try to plot the receiver operating characteristic curves which are important when it comes to the machine learning. Also we can try applying different sort of other machine learning techniques, and these are our references for the project. Hope you like our project. Thank you.